If you're looking at the lathe at the auction, or maybe at somebody's garage, and there is no power connected to the machine, that does not automatically mean you should walk away. But it does mean you need to know what you're exactly looking at. In this video, I'm going to show you how to inspect a machine without power. What areas we need to look at, what areas matter the most, what's area most expensive, and either you should proceed or just walk away.
A lot of people make the same mistake when they buy a used machine. They look at the paint, they look at the size, maybe they spin a handle or two, and they think they have a good idea of the condition. But with industrial equipment, the expensive problems are usually not cosmetic.
The real money is hidden in wear, mechanical damages, missing parts, and electrical issues.
Before we go any further, let me be clear. This video is not a substitute for a full professional inspection. It is based on our practical experience, and the best thing you can do is bring somebody qualified with you. If you can hire a mechanic for a couple of hours, that can save you thousands. But if you do not have that option, this video will give you a solid inspection framework.
Also, before you even drive to see the machine, do your homework. Check if machine is still supported. See if it's any dealers in the area. Check if spare parts still available.
Check whether the machine is common enough that parts can be sourced or reproduced at a reasonable cost. Here in North America, if parts are no longer made, getting them can become very expensive very quickly.
Now, let us say you're standing in front of a lathe. The easiest way to stay organized is to inspect machine in one consistent direction.
We are going to inspect this lathe in one simple direction, moving counterclockwise so we do not miss anything. We start with the bed, then move to the headstock, the feed box, the lead screw and apron, then the cross slide, tailstock, electrical cabinet, and accessories. For this inspection, all you really need is a pry bar, a dial indicator, and a rack. The goal is not just to find wear, but to understand the cost of a bad decision.
We're gonna start with bed. It's one of the most expensive and most important components of entire machine.
If the carriage is sitting close to the chuck, move it out of the way first. The reason is simple. This area of the bed is usually one of the most heavily worn sections, and if the carriage is covering it, you will not see the real condition of the ways. Move it aside, expose that section, and inspect the surface carefully.
So, what we're looking for here, basically, we want to see what's going on with the bed condition. So, once we remove carriage to the right, what we're going to see is most worn out area right about here. So, everybody pretty much using machine right here. So, move it away, start to check right here. For reference, we can use the back side of the machine. Carriage normally never goes that way. So we just can come, have a look, and right here we can see. So the bed usually like brand new, right here. Back side, opposite side. So now we look right here. Just put your fingers right there and move it up and down. You're gonna see it. You're not gonna miss it. Like look at the top and look at the bottom. You're gonna feel it. Put your nail and move it up and down. The best way, in same time, just to grab this guy here and to move it back and forth. See right here, we go from the middle up and see here is a jump right there. So on this particular one, we're talking about 7-hour wear. So the same, you're going down, and usually on the bottom there is one more step. Sometimes yes, sometimes not. Now see, like in our case, we're talking about 4 to 5 hour jump right here. Here is one more example. So normally your wear happens on the back side because your pressure always coming from your tool point this way, and right here we have right in the middle we have step
If the bed wear exceeds about 0.010 of an inch, that is already a serious red flag. On smaller manual lathes, especially machines up to roughly a 25-inch swing, rebuilding the bed is often not economically justified. The cost of proper repair can easily reach $20,000 to $30,000. At that point, you may already be in the price range of a very good used machine, and sometimes even close to a much newer one. On larger machines, in the 25 to 40-inch range, this does not always mean you walk away immediately, but it does become a very strong negotiation point. So the logic here is simple. If the bed is clearly worn out, you either adjust the price very aggressively or you turn around and walk away.
Now let's move to the headstock. Usually it's one of the most expensive, most complicated parts of entire machine. Let's try to shift some gears here and see if actually your handle's gonna move.
Since we cannot power the machine on, our goal here is to check as much of the headstock mechanically as possible. We want to make sure the speed selectors are shifting, that there are no twisted shafts or obvious internal damage, and that the spindle can still rotate freely.
On some machines you can find neutral position. So in neutral position it's relatively simple to rotate the spindle and estimate the resistance.
We also want to check spindle play and smooth free movement. If you can open the headstock cover and look inside, that is ideal, but in many cases you will not be able to. Here is a very good example of what broken gears inside the headstock can look like. For illustration, we remove the headstock cover so you can actually see the damage. But even if you cannot open it, you can often still catch the problem by rotating the spindle by hand. If the movement feels uneven, jerky, or you notice knocking, that is a strong sign that something inside is damaged.
So once you see everything is shifting, say like you cannot open that cover, at least you know your shaft's not twisted, and you run your spindle, it's running smoothly. Let's check your play in a spindle, and we're gonna use this tool accessible everywhere. So just install the dial indicator as close as possible. Do not try to put it on a chuck itself, try to put it on the spindle end, and let's move it up and down, we'll see what happens. See, like in our case, it's not even 1/1000, so I apply pretty good force, but it's not moving, so it means in that particular unit, spindle bearings appear to be good.
The headstock is one of the biggest cost risk areas on the machine. There are a lot of gears and internal parts inside, and if you cannot buy replacements, expect to pay at least $1,000 per gear to have them made. If you can open the cover and inspect inside, that is ideal. Sometimes you will find water, contaminated oil, or clear signs of internal damage. At minimum, always check the oil and inspect as much as you can.
Now let's move over to the feed box. Compared to other components, this one is usually one of the less loaded. It's running usually at a low speed, no heat, and causing less concern compared to another components.
Use the same basic check here as on the headstock. Move the levers, make sure everything shifts, and if nothing feels stuck, you are most likely fine.
One more thing you want to check right here, it's your rack condition. And again, like everything else, like your bed, like your lead screw, if rack is worn out, it's going to be worn out right about here. There is some chances those rack sections might be interchangeable back and front. However, they assembled so close and they actually pin right to the bed, so you might need to do a little bit of work to reposition them. So it might be a little bit of problem, so be careful right here. Move apron at least a few inches back and forth to make sure that pinion shaft has no missing teeth.
If so, you for sure will feel the problem when rotating handle.
So the next gonna be is a lead screw and feed rod.
First look at the feed rod. Usually there is not much to worry about here, just make sure the keyway is fairly even. Here is an example of heavy wear.
Here is a great example of worn out lead screw. On that particular unit, lead screw is symmetrical and somebody already rotated, and right here we can see how much wear on the screw. Sometimes a lead screw might be symmetrical, so the left hand side and right hand side are the same, so can rotate it 180 degrees and use that area over there as brand new one. You look at the end connections. If it's matching opposite side, there is a big chance you can flip it around. Now, normally machine would work right about here where people cut the thread, so you just look right here. If you see pitch variation or wear in that area of the lead screw is visible by eye, it's definitely wore out. Speaking of the replacement cost here, lead screw expensive. If you're not able to buy it from your distributor, you would have to make it. Might cost you $3,000–4,000 easy. Now we get to the apron. In many cases, the apron is the worst area of entire machine. It's located close to cutting area, lots of coolant splashing around, and all this coolant, believe me or not, through the bolts, through gaskets, through sometimes gap in the crossweight area, ended up right inside there. The second reason why it's so bad, in most of the cases, the lubrication for your crossweight area and for carriage taken right from inside the apron. So inside the apron you're gonna have oil pump, and every time you move that carriage left and right, it's automatically supply the oil to those areas, and sooner or later there is no oil there. Some machines do have actually external oil, and this way oil inside the apron is preserved. However, with coolant splashing around and getting inside there, sometimes it's just simply overfilled and totally rusty, so worst part of entire machine. As normal, what we're doing here, we're gonna check the oil level in a side glass. See if it's even present there or not. Sometimes it's too much, sometimes it's nothing. I do not see often oil level is in place. Machines working with no oil yearly, like many years, nobody care about it usually. So be ready to rebuild this thing. So in order to check what we're gonna do here, first of all, you need to make sure the control levers actually moving. Now, every time you move, for example, for crosswise direction, it should lock your crosswise. Disengaged. Engaged. Same for longitudinal. Move the lever, lock, neutral, move, lock. So it might tell you right away, so everything here is at least working as it should work. However, some machines has electromagnetic engagement, so no matter how you move the joystick, it's not going to be any reaction on the handles. Here is a good example. No matter. So no power, no resistance. So same way for longitudinal. One more thing we need to consider, we need to check. Actually, it's a half nut condition. So half nut lever usually located on the right hand side. So make sure your feed is disconnected and then move handle down or up, depends on the machine, engage the half nut. So now the carriage not gonna go anywhere. We can check actual wear of half nut. We're gonna use our dive indicator, install it on a carriage or crosswise, whatever, and we're gonna move carriage by the handle left and right. So half nut engaged, and let's see. So right here we have a 50 thou, and I can definitely see the backwash happening between apron and the lead screw. So which means we have wear of our half nut in the range of 50 thou. Now consider the heavy pitch of the lead screw. Normally they're pretty coarse. 50 thou is not so bad. What you don't want to see is something like half of the pitch. Say like you have 4 threads per inch, you have 250 thou. If your backlash is about 100 plus thou, you're gonna be ready to replace that half nut soon. So now once we're done here, we're going a little bit up and we're gonna check the crosswide right here. So the idea is, again, like everything else, crosswide mainly works close to about the center of its travel. So move it a little bit away. And easy way to check it, if machine is not so big, like our particular one, is basically install dive indicator. Again, on the carriage, put it against compound, and just basically grab it by hand and move it. So here we go. 60 thou backwash. So the next step will be, we're gonna separate backwash and wear. Backwash basically is relatively simple to adjust. However, wear, in our case of the crosswide screw, not so easy. You most likely would need to replace it. So let's move crosswide away. So we just move crosswide close to operator, and basically it's an area where machine not quite often works. So by moving crosswide, we're gonna see how much wear we have here, how much backwash, and so it's gonna tell us how much actual crosswide screw wear we have. So as you can see, it's about 50 thou backwash right there. About 60 in the middle, about 50 here. I'm not talking about exact numbers, but we're talking about 10 thou of difference, means that 10 thou built into the crosswide screw. Now on heavy machines, on bigger units, sometimes crosswide is so heavy so you cannot basically shake it. It's just too big. So what we're doing here, so same principle, but instead of shaking it, we're gonna rotate a handle and see what our dive indicator gonna show us. So we're gonna set up dive indicator same way, and we're gonna rotate the crosswide handle in any direction, reach some reference point, say 0, set your dial at 0, and keep rotating same way as much as you want, like say a quarter revolution, no matter how much it's going to show you right there. Stop at some point and start to reverse it, and come back to the same reference point, which is 0 in our case. So here we go. We have about 19 thou of backwash. So we already 0 here, but over there we did not approach our previously set up number, and the difference gonna show you how much backwash you have. And pretty much same principle you can use for your compound slide. So it's the same idea. You have a screw, you have a nut. So instead of put your dive indicator on the cross slide, just put it on your compound slide, set it up, and do the same procedure as you've done with your cross slide. It's much lighter unit. Sometimes, again, like it's even on large machines, it's easy to move. See, we have about 20 thou right there. If it's too heavy, again, use the same principle. Use your dial to estimate how much wear on the screw you have there. Now let's go and check couple remaining items. So we have a tailstock, extremely simple unit. However, you need to check couple items on it. First of all, bore. Look inside. See if it's actually clean, beaten up. Even if it's a little bit beaten up, you can always use lapping compound and kind of remove high spots on it. In the same time, sometimes tailstock has high and low gears sets. Like for example, right here, make sure actually you have ability to move your tailstock and gears shifting properly. Now for example, we're on the high gear, and when we try to rotate to the low gear, you can use your gear drive right here, and in our case machine is working properly. I would say the last unit, and it's optional one, not every machine has it, but some do, it's your taper attachment. It's pretty complicated unit. You have two sliding surfaces plus connection to a point in the middle here, connecting your crosswise screw with taper attachment. So check on the wear right in those areas, right here on the square block and on the V bottom plate. You might see the wear. Usually taper attachment does not protect it by wipers like your carriage, so it's wearing out pretty quick. But another main thing with this unit is missing components. Sometimes when people do not use it, what's going to happen, it's present, but say for example on this machine, you have bar and bracket missing. So those two units gonna cost you, if you cannot buy them, it's for sure a few $100 right there. So once we complete with mechanical portion, the last what you can check here on the machine is basically your electrical system. So find the electrical cabinet, open it up, and just simply look inside. So if everything present right here, something missing, some loose wires, is for example you have some missing spots or loose wires, it might tell you so it was some sort of issue with the machine. So maybe somebody tried to fix it but wasn't lucky enough, and this is maybe why you're looking at this machine at this place. If you get in a machine for your acreage, or you have limited power supply, let's say single phase to 20 volts, you better get 220 volt machine, because otherwise you might need to get power transformer, rotary phase converter. It's going to cost you a little bit more. Check machine safety compliance. Say in Canada we have CSA certification, which allows you actually to use machine locally. If you do not have it, be ready to recertify the machine, and it might be as low as a couple $100. On the high end, I would say probably no end, thousands. Look at the machine nameplate and verify the voltage. Some European machines from Asia sometimes come in 380 rare configuration voltage supply. So means you most likely would need to get a power transformer.
After that, look at the accessories, because this is where a machine can gain real value.
Does it come with steady rest? Does it come with digital readout, follow rest, extra tool holders, tooling? It all costs money at the end. Those are not small details.
A digital readout system alone can be worth $2,000 to $5,000 depending on brand, condition, and whether installation is included or not. Tooling also adds up quickly, so accessories do not just make the machine nicer, they affect the real economics of the deal.
Now, let me simplify the whole process into practical decision. If bed is badly worn, headstock show major damage, you have missing parts, usually a walk-away machine.
If the machine is larger, structurally decent, and the issues are known and manageable, it may still be worth considering. At that point, it becomes a negotiation machine. If the machine is complete, the major assemblies look healthy, the wear is reasonable, and the risks are understandable, then maybe it is worth moving forward. That is the point of this inspection. Not to prove the machine is perfect, because you cannot do that without power and deeper testing. The goal is to decide whether you are looking at a reasonable risk, a negotiable problem, or an expense.
One final point. On our experience, machines at the auctions are usually there not because they are totally destroyed. Very often business close, production changes, they need an upgrade, or simply need a space. So do not assume every machine there is a scam. But also do not assume you are safe just because machine looks solid from outside.
This is industrial equipment. The prices are commercial. The repairs are commercial. The parts are commercial.
Mistakes here can become expensive very fast. So if you can, bring a qualified mechanic.
And if you cannot, use this inspection path as a practical framework
to help you make a better decision. Thank you for watching.